Hello, everybody. This is Dr. Ma, and this is the introduction to exponents. Um, Exponents is a very simple idea of trying to track how many copies are doing something. In this case, multiplications. Uh, but it also causes the most confusion when we start to abstract the notations of exponents. And the problem I'm talking about is for example, let's have a example. 0 times 5 versus 5 raised to the 0 power. Okay. And let's follow our trend of thoughts. Okay. If I write down 2 of 5, 2 times 5. Okay. And that means 2 copies of 5 added. Okay. And then we will say, oh, 0 times 5, if I were to change of 0 to the 2 to 0, on these I have nothing added, so I get nothing. And we try to carry the same internal thoughts into these notations. And we all know that 5 squared means 5 times 5. And that's 25. And now come these very strange questions of what's 5 to the 0. And now, of course, what we'll think, the first reaction is, oh, 5 to the 0, there's no 5 multiply. So if there isn't anything, it's nothing. If it's nothing, it should be 0, right? Same as before. I mean, there's nothing. Either you add or multiply, you get nothing. It shouldn't be the answer equal to 0. And of course, the answer is not, it's 1. And this is where students sit back say, no, it doesn't fit with my internal dialogue, the logics that I learned in whatever my natural language is, English or whatever. Okay, and so let's clarify that a bit. Okay, the basic idea is what we have to differentiate is the difference between coefficients and exponents. When we say take an apple, add it to itself multiple times, and so the number of times added is 4, so the coefficient we call is 4. And as below, if we were to multiply these apples, or whatever that means, and there are 4 copies of apple multiplied to the 4, and the exponents is 4. The precise way to define coefficient is that number of times is added to starting with 0. So if there's no apple added, 0 apple, so this number will be 0, then of course you will get a 0 back. And correspondingly for the next multiplications, we're talking about number of times an item multiplied to the number 1. We start out with a number 1. Hence, when there is nothing here, okay, that means 0 power, and that's the answer is 1. So this is a short graphic reason that the pointing out the difference between the two operations, additions and multiplications. In other words, the symbols dictates us that we should set 0 power to be 1. Okay, once we have these, then this notation is very useful because we have the following rules that allows us to convert operations from multiplication to adding exponents and dividings is crossing out copies of the exponents. In this case, divide by 2 means cross out 2 copies, and so we only have 3, 5. So that's we subtract the exponents, then power to power. And this is how many sets of powers do we have. So we multiply the number of the exponents to the how many sets. So you will get 3 to the 12th power and 2 to the 6th. Okay, so that's how we use those rules to compactify expressions of exponents. And here come the ones that are not very intuitive. Okay, a to the 0 is 1. Here's another reason why that is true. Because when I divide, I get a divided by a is 1, but I also subtract the power. So a to the 0 power on one end and 1 on the other end, so they're the same. Once we realize that, then the brain kind of like, oh, wow. I mean, then we can start talk about things like different things like negative powers, which are reciprocate, and the square root actually is half power, cube root is third power. So fractional powers actually is taking roots. So these are things you can take a look at. And finally, we'll arrive at the interpretation of this a quantity raised to a fractional power. And how do we interpret this if we need to calculate a number? What is it asking us to do? And the way we interpret this is always starting from the denominators of the fractional exponents, meaning we're going to take the roots, the nth root first. Then where do we put the k's, plus minus k? Well, you put it outside because the multiplications tells you a power to power, you multiply these two numbers, you get back to the original. Therefore, I can move the k outside. So hence, if I interpret it this way, it's asking us to take the roots, then take the power k. So these are examples of what we do. First one, take the square root for the 9. Second one, take the cube root. Third one, C, take the fourth root, etc. And then process it further. Then what are fractional decimal powers? Before that, here's examples of how we collect powers. Okay. This is not to be turned into cube root or square root. No. These are exercise on collecting powers and cleaning up, consolidating X powers, Y powers. So we use rules from the power to power rule, and then we use the rules, the adding power to consolidate the X, consolidate the Y, some use the divisions to subtract the power and arrive at the final answers. So the whole exercise actually is adding, subtracting fractions, of course. But this fraction, of course, actually meaning taking radicals, taking roots and the raise power to another power. And we can interpret roots into fractional power and back and forth. And here's the problem with taking roots together. And how do we interpret that as all these taking roots multiplied, taking fourth root? How do we simplify that? And well, here's the rational power comes in. I can interpret them as fraction power, then add them as fractions, and then reinterpret back into root radicals. So actually, this is the 12th root raised back to the 11th power. And his decimal powers is to be interpreted as fractional powers. And so these are some examples which we can actually calculate. Of course, here's one that we cannot calculate. So we need a calculator on these. And a little bit on scientific notations. So positive powers means you keep multiplying. Okay. Third positive power. And negative power means you keep dividing. So if you divide 1 by 10th, 1/10. If you divide by 10 again, -2, so divide twice, meaning so 0.01. So this is the pattern for the negative exponent. So this is the exponents is the scientific, we use in scientific notations. It's also the numbers on your calculator. At the end, if your number is very large or very small, usually on a calculator, okay, let me create like 993 factorial. See this 144 plus, that's the exponent says 144 power up here, meaning 144 zero behind it. You have to multiply the front by this particular number, one with 144 zero behind it for your answers, approximate answers. That's it. And do the art homeworks and have a good day. Bye-bye.